So on number 1, how many things are marked on each of the 2 triangles that we are looking at? How many pieces of information are marked for us? We have this triangle right here. And then we have this triangle over here. How many corresponding congruent parts do we have between the triangles? I've got one side right here. Has anything else been marked for us? One angle. This angle here is congruent to this angle here. What's the minimum number of pieces that I need to be corresponding congruent parts? I need 3. I only have 2 right now. I want you to look very carefully right here. That side, HJ, is part of both triangles, right? It's kind of the dividing line between those 2 triangles. If I were to cut out this parallelogram shape and cut it alongside HJ, I would have my 2 separate triangles. Is HJ the same size as itself? Yeah. It's part of both triangles, and it's the same size as itself in both of those triangles. So we can mark this shared side as being congruent between the 2 triangles. I know it's congruent because it's part of both of those triangles and it doesn't change size between those 2 triangles. Now how many corresponding congruent parts do I have between the 2 triangles? I've got 3 pieces. Which 3 pieces do I have? Do I have side, side, side? Do I have side, angle, side? Do I have angle, side, angle? Which one of these do I have? Side, angle, side. Here's a side that's congruent, and then an angle, and then another side. So my congruence criteria here would be side, angle, side. What about on number 2? How many corresponding congruent parts do we have? We've got 3. So I don't have to work for any more of them there. I've got all 3. Does it meet one of the 5 congruence criteria that I have? Which one? Side, 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 yes. All right, I want you guys to go ahead and pull out your notes. We're going to pick up where we left off yesterday. We had just started looking at triangles and matching up which congruence criteria we can use with what we've got. So we're on the back side of the 2nd page still. Or sorry, no, we're on the 3rd piece of paper. My apologies. 3rd piece of paper. We did number 4 parts A and B together yesterday, so we're going to start off with C and D next. Let's look at C first. Between these 2 triangles, do I have any pieces that I can mark as being congruent? Angle Y, right here, is congruent to what in the other triangle? Angle M. What else do we have that we could mark congruent between the 2 triangles? I'm sorry, you said ZX right here. And which one on the other triangle? NL right here. So this side is congruent to this side. Are there any other pieces that we can mark congruent between these 2 triangles? ZY and NM or MN right there. This is congruent to this. How many corresponding congruent parts do I have? 3. 3 corresponding congruent parts is my minimum. So now I have to see, is it one of the 5 that I've got? What are the 2 that I'm never allowed to use? SSA, because if I turn that around, yep. So side, side, angle, or that's the same thing as angle, side, side. So that's one of them. What's the other one that I can never use? AAA. I can never use angle, angle, angle. Because it's possible for me to have two triangles that have the same angle measurements. They look the same, but one is a tiny version of the other. So the angles would match, but the sides wouldn't. All right, so we can never use side, side, angle, or angle, side, side. That one's easy to remember because it spells something that you're not supposed to use on school papers if you write it out. It doesn't matter if you swish it around, it still doesn't work. I had somebody point out yesterday, I thought this was very creative, that said an easy way to remember that you can't use angle, angle, angle is because it looks like a scream when you write it down. It's ah. What do I have here? Do I have side, angle, side? Do I have side, side, side? What do I have? Side, side, and then an angle, right? Is that a congruence criteria that I am allowed to use? No. Side, side, angle does not prove congruence.
So it matters which way you write it.
Nope. Does not matter. Side, side angle is the same thing as angle, side, side. But it does matter when you're looking at this, you have to pick an end to start on. You never start in the middle. So I would never start with this piece right here. I would have to start with either this one or this one. So good question. If I choose this one to start at right here, I have to move to the next closest marked piece. If I go this way, I am not moving to the next closest. The next closest would have to be this one right here. So that is a great question. I'm really glad you asked that and pointed that out. The order that you go in doesn't matter. You have to pick an end to start on. You never start in the middle. And you have to move to the next closest piece. You can't ever take the long way around. All right, let's look at D. How many corresponding congruent parts do we have between those two triangles? 3. I'm going to outline my triangles. I'm going to do one of them in orange. And I'm going to do the other one in a dark blue so that we can refer to these by their color. All right, so I have 3 congruence criteria. Or I have 3 corresponding congruent parts, sorry. So which congruence criteria, if any, could I use here? I have an angle here. What's on either side of that angle? There's a side up here, and there's a side over here. So my angle's in between. That angle is included. It's being hugged by those two sides. So when I'm trying to figure out what criteria to use, I can't start here because he's in between those two sides. I got to pick another one to start at. I could start here, or I could start here. But no matter which way I go with this, we would call it what? SAS, side, angle, side. Is that an allowable congruence criteria? Yes. So I would say, yes, I have enough information here. We're going to say that they are congruent to each other by side, angle, side. And now I have to write my triangle congruence statement. I have to make sure to match up my corresponding congruent parts. The way we name the first triangle does not matter. The way we name the second triangle, I have to make sure that I have that in an order that matches the first one. So what do you guys want to name the first triangle? JO is a line segment. I need a triangle. So JO. Oh, DJO. I'm sorry, I just didn't hear that first letter. DJO. DJO. So I have to make sure that I'm matching up my corresponding congruent parts. Something that I notice is that angle D, what we started off with, that's not touching the shared side. So when I go to write my other triangle statement, I need to choose the angle that's not touching this shared side, which would be which angle? Angle P. So I have to start my other triangle congruent statement with P. All right, let's pay attention to our order. It went D and then J. So P, let's see, D and then to J. That's a side that's been marked with a congruence mark, right? So I have to make sure that I go from P and I have to follow along the side that has that congruence mark on it. So that would take me from P to what? P to O. Once I have two of them in order, the third one's pretty easy. This is going to be triangle PO what? POJ. These are congruent sides. Make sure that you're matching up your corresponding congruent parts. All right, let's try two more like this here. Do I have enough information in part E to say that these two triangles are congruent to each other? Yes. Using what congruence criteria? Side, 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 angle, 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 side, or hypotenuse leg? Angle, angle, side. A, and then here's my side. So angle, angle, side. You can do that as side, angle, angle. The order that you write it down in does not matter. Angle, angle, side is exactly the same thing as side, angle, angle. Let's write our triangle congruence statement. So triangle something is congruent to triangle something else. What do you guys want to call the first triangle? ABC sounds good. A, B, C. Angle A, we have some information about. It has two little congruence markings on it. So that has to match up with which angle on my other triangle? F. And then I notice that angle B up here has one arc marking on it. So that has to match up with what on my other triangle? E. So triangle ABC is congruent to triangle FED by angle, angle, side. Last one in this section, part F. How many corresponding congruent things are shown in the picture? 2. But what else do these triangles have in common? They have a shared side. That shared side will always be congruent to itself. So if it's not already marked for me in the picture, anytime I see a shared side, I'm going to mark it as congruent. Do I have enough information to say that these two triangles are congruent to each other? Yes, using what congruence criteria? Side, side, side. All right, let's write our triangle congruence statement. We got to be careful here. For the first triangle, I like to try to make it easy on myself. We don't have any information about angles, so I'm going to pick an angle that I can't screw up. Here's C, and it's not touching the shared side, right? So if I start this triangle congruent statement with C, I need to start the other one with what? For my second triangle, what would have to come first? B, because B is not touching that shared side. So far, so good? Now I'm going to look at a line segment. Why don't we go this way? So that would go from C over to D. And I notice it has two congruence markings on it. Down in my other triangle, we already said that we're starting at B. I have to go from here, and I have to follow the path of the side that has two congruence markings on it. So that's going to take me from B to what? B to A. All right, so help me out with this. That's triangle CD what? CDA is congruent to triangle BAD. Absolutely. So we have CD is congruent to BA. These are congruent sides. When I ask you guys to write a triangle congruent statement for me, you don't have to say something like this. I just put these notes up here about the congruent sides and angles to make sure that we know what we're matching up. Because if you had triangle ACD is congruent to triangle BAD, that would not be correct because you're not matching up your corresponding congruent parts and it would be marked wrong. All right. What we practiced starting yesterday and what we just finished up now, when we have triangles that are all marked up for us, can we pick out which of those 5 congruence criteria we have information about? We're going to do the exact same thing, except now we are going to be the ones marking up these triangles. So before we practice marking up these triangles with given information, I want to make sure that we understand what we're doing and why. So we're going to look at things that could be given to me in words and what that means I'm going to do to my picture. So if we see either midpoint or median, we are going to mark 2 segments or sides congruent from one longer side. So just to give us a little example to look at here. If I have a side that I'm looking at and it has points A, B, and C on it, and I am told that B is the midpoint of AC, then I can mark these 2 segments congruent to each other. If I know something is a midpoint, then I know it is splitting it in half. So those 2 sides would be identical. If I see that 2 sides are perpendicular, sometimes you're going to see this symbol instead of the word perpendicular. Perpendicular means that 2 sides are coming together and forming a right angle. So if I'm told that 2 line segments are perpendicular, then I'm going to come in and I'm going to mark them as perpendicular, as right angles. If I am told that 2 lines are parallel, sometimes you're going to see this symbol here instead of the word parallel. Do you guys remember when we talked about parallel lines and transversals? And all the different special angle pairs we had, like alternate exterior angles and consecutive same side angles. Do you guys remember doing that? We're going to be looking for parallel lines as we are marking up these triangles. And when we see parallel lines, we are going to mark our alternate interior angles as congruent. When I'm looking for alternate interior angles, I'm always going to be trying to make either a letter Z or a backwards letter Z. I'm going to mark my 2 parallel lines, and then I'm going to find a transversal that connects them. So see what I've traced over in orange, how it kind of makes a Z shape? My alternate interior angles are going to be tucked into those corners. They're on opposite sides of the transversal. This one's below the transversal, this one's above it. And they each touch a different parallel line. If you are told that a side bisects a side, what does bisect mean to do again? To cut it in half. So similar to a midpoint. If I see that something is bisecting a side, I'm going to mark two segments or sides congruent. From one longer side. If I am told that a side bisects an angle, I'm going to mark two angles congruent. From one larger angle. So I'm going to draw a little picture here. If I have a big angle like this, and I am told that this orange segment right here is bisecting it, then that means that the two smaller angles that are formed are congruent to each other. Things that I am always allowed to mark, and these are things that I will always mark first. We can always mark the vertical angles congruent. And we can always mark the shared side congruent. When I mark a shared side congruent, that is my reflexive property because I'm saying it's congruent to itself. So vertical angles always get marked as congruent. And shared sides always get marked as congruent. Let's practice doing this. Once you finish getting this written down and your drawings made, please go ahead and flip the page. Then go over and get some. They're always over there. All right. Let's look at this one. We're going to practice marking our triangle and then figuring out what congruence criteria we can use. First thing they tell me is that segment AB is parallel to segment CD. That's what these little triangle markings mean here. This guy right here and this guy right here. These mean parallel. When I have parallel lines, what did we say we're allowed to mark on the picture? Which thing? I can mark vertical angles on this picture, absolutely. That I can do without any congruence criteria at all. I can come in here, this angle right here is congruent to its vertical angle on the opposite side. All right, let's see what we can do with our parallel lines now. We are told that parallel lines AB and CD exist. So CD is up here. AB is down here. Is there a diagonal transversal that is connecting those two? Is there any lines that are on the picture that are connecting those parallel lines? Yeah. I see two. I'm going to look at just one for starters. I can look at this one right here, AD. It connects my two parallel lines, and that means I'm going to have not vertical angles. I have alternate interior angles that I can mark as congruent. I can make this Z shape on my picture. If I can make that Z shape with my parallel lines, then tucked back into these corners, I have alternate interior angles and they're congruent to each other. What about if I went this way? Is that still using both of my parallel lines? Is it being connected by a transversal? Yep. CB is my transversal here that's connecting those two parallel lines. So I've got another set of alternate interior angles that I can mark, tucked into these orange corners. So angle C over here would be congruent to what on the other triangle? Angle B. Do I have three corresponding parts that are congruent between these two triangles? I have three corresponding parts. What three parts do I have? Angle, angle, angle. Am I allowed to use angle, angle, angle to show triangle congruence? No. Makes me scream when it happens. I need more information than that. We said we have to have at least one what if we're going to show triangle congruence? At least one side. And they gave me that right here. It says segment EB, this right here, is congruent to segment CE, this right here. Now do I have enough to say that these two triangles are congruent to each other? Do I have enough? Yes. Using which congruence criteria? Which of the five could I use here? There's more than one right answer on this one. I can use angle, side, angle, because here's an angle, and then a side, and then an angle. So I can use angle, side, angle. Or I could use angle, angle, side. I could come over here, angle, angle, side. I could use either one of those here. Does not matter which one I use. Both of those will show that my triangles are congruent. I'm going to use angle, side, angle for this one, just because I think it's easier to see on the picture. And now I need to write my triangle congruence statement. How do you want to name the first triangle? Give me a way to name our first triangle. I heard, you said, I'm sorry, one more time. A. Oh, DEC, sorry. DEC would be our first triangle. We have to match up our corresponding congruent parts. Because we have all the information about my angles, I can make sure to match up my congruent angles. Angle D is congruent to which one on the other triangle? A. Angle E is congruent to E. And angle C is congruent to B. So angle DEC is congruent to angle AEB. Let's go look at number 3. We've got a couple more to practice with down here. Before I even read my given information on this first one, when I see this shape, I know there's something that I can mark before I even read anything. What can I mark as congruent in that picture? Segment BD. This is a shared side between those two triangles, so it is congruent to itself. I can mark that. It then tells me that segment AD, this one over here, is congruent to segment CD, this one over here. And then finally, it tells me that segment BD bisects angle ADC. Well, BD is right here. What does bisect mean to do again? Cuts it in half. It's cutting an angle in half. I need to figure out which angle that is. The middle letter always tells me the vertex of the angle. What is the vertex of the angle that's being cut in half? D. So the angle that's being cut in half is this guy down here. So that means this angle right here is congruent to the other side of it. Do I have enough information to say that these two triangles are congruent to each other? Yes, I do. Using which congruence criteria? Side, and then angle, and then side. So I can use side, angle, side here. What should we call the first triangle? What do you want to call the first triangle? The order that we name the letters in does not matter on my first one. ABD. Sounds good. Triangle ABD. I have to make sure to match up my corresponding parts. So A is out here by himself. C, B, D, yes. Part B. There's something I can mark on this picture. FH. I'm going to use my reflexive property and say that is congruent to itself. And then it tells me something interesting about FH. It says that FH bisects angle EFG. So FH, this guy right here, is bisecting the angle with a vertex of what? What's the vertex of angle EFH? F. So right up here, this is the angle that's being cut in half. That means this angle is congruent to this angle. And then it tells me that FH is doing more bisecting. It's bisecting angle EHG. Where should I look on the picture for angle EHG? What's the vertex? Down at the bottom. The vertex is H, so I'm looking at this angle right here. That's EHG. That angle is being cut in half, so those two sides are congruent. Do I have enough information to say that these two triangles are congruent to each other? Yes, using which congruence criteria? Angle, side, angle. Here's my angle. Here's my side. And here's my angle. Give me a way to name one of those two triangles. H. H to what? Because I need a whole triangle, so I need 3 letters. HEF, I like it. HEF. That's this triangle over on the left. H in the left-hand triangle is congruent to what on the right-hand triangle? H. And then E was out here. What does that correspond to on my other triangle? G. So H, G. And then once I have my first 2 letters, the third one should be easy. F. HGF. Should match up all of my corresponding congruent parts. All right, let's go look at C and D. First thing I notice on C is that it tells me JM and LK are congruent. So here's JM and here's LK. There's something I should have marked before I even did any reading. Shared side MK right here. Sometimes I miss that and don't catch it till the end because I get too excited about reading all the given stuff. But you always want to make sure that you're marking your shared sides as congruent. It tells me JM is, and then it has this funny little symbol. What does that symbol mean? Perpendicular. When I see something that says perpendicular like that, what kind of a marking am I going to put on my picture? Right angle. So I'm going to go find where those two segments meet. JM, right here, and JK, right here. Where are those two segments meeting? Because that's where my right angle is. At J. So there's my right angle. I do the same thing for this last piece of information because once again we have perpendicular. So I need to go find LK. Here's LK. And ML right here. Where they meet, it forms a right angle. Where are they meeting at? At L. So that's a right angle. Do I have enough information to say that these two triangles are congruent to each other? Yes. Using which congruence criteria? Which pieces do we have marked here? I see an angle right here. And then what? A side. And then I have to move to the next closest thing, which would be another side. Oh, can I do that one? I can't do that. But what kind of angle is this here? It's the HL1, hypotenuse leg. This guy right here is across from the right angle, so that is my hypotenuse. That's my shared side, and we know it's congruent. How would I write this triangle congruence statement then? Give me one triangle. JMK. Angle J is congruent to what on my other triangle? L. Hold on, I went from J to M. That's my side marked with a congruence mark. So I have to make sure that that matches up in my other triangle. So L, K, and then M. All right, one more. I know we're almost out of time. It tells me here that NO and PQ are parallel. Well, here's NO up here. Here's PQ down here. Is there a transversal that connects those two? QO. So I can mark alternate interior angles here. So O up here and Q down here. It tells me that NQ and PO are parallel. NQ and PO. Is there a transversal that connects those two? I'm sorry, which one? NO? NO is this guy right here. I want to know if there's a diagonal line that connects those. I like what you saw. OQ again. So I have another pair of alternate interior angles here. Can we mark anything else on this picture? Shared side right here. Do I have enough information to say these two triangles are congruent? Yes, using what? Angle, side, angle. All right, so NOQ, I'm going to name the first one. How would we name that second triangle so that it matches up my corresponding parts with NOQ? PQO. I started out here, so I have to start down with P. That's a corresponding part. I moved across my long side, so I have to move across my long side. Please don't forget your homework is due tomorrow, guys. Bring that with you. We will grade that. We'll do a little bit more practice, and then we will start doing some proofs.